Hi, fourth graders. Mrs. Brand, we are set to do our lesson for today, and we are going to be on lesson 92, and we're going to take a look at some of the different shapes and stuff that we have, some that we've already talked about and some that we still need to learn. Okay, so first of all, one of the main things we're doing is learning the names of different types of shapes. So the first shape we have is the quadrilateral. The quadrilateral is the four-sided polygon. Okay, a four-sided polygon. Polygon is any closed figure with straight lines. So a quadrilateral, quad means four, so we have four-sided figures. Here we have a four-sided figure. Here, 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 all of them just four sides. That makes it a quadrilateral. Okay? Now, let's take a look at our next word. Parallelogram. Parallelogram, parallel. We have those, and like I've told you before, the two L's in parallelogram help us see what parallel lines would be. So when we have these two lines right there, looks like I need to go back and get my pen. Okay. Yeah, let's do that. Okay. And let's see if we can get a different color, but fine. Parallelogram. Parallel lines. Those L's are parallel. So to know what parallel lines would be, they go straight alongside each other, but they never match up. So here we have a set of parallel lines, and we have another set of parallel lines. They'll keep going and going. They'll never touch each other. On the rectangle, we also have the parallel lines and two sides parallel lines. This one is the one that kind of we might look at and go, I don't know. But it's just a square that's kind of smushed to the side. So we have a set of parallel lines here, and we have a set of parallel lines there. So two pairs of parallel lines. Not just one, but it has to have two pairs. So all of them are like the figures that we see right here. Okay? Parallel lines, they go side by side. Two sets of parallel lines going side by side. Okay? So quadrilateral, four sides, and it's a four-sided polygon because it's a closed figure like this with straight lines. So these are also all quadrilaterals, four-sided figures, right? All right, so parallelograms, four-sided figures. Now, trapezoid. A trapezoid has exactly one pair of parallel sides. So on this one, the top one and the bottom one are parallel to each other. These ones, let's change that color a second just so we can see what I'm talking about a little better. Okay? These ones are not parallel. If they go down, they're eventually going to cross each other. But the top one and the bottom one, those are parallel. They're going to keep going on and on and on. So it has one set of parallel lines and one not set. That's a trapezoid. A trapezoid. Okay? If we were going to make our own trapezoid, we would make one set of parallel lines that are not the same length as each other, and then we would just connect them and make ourselves a trapezoid. Okay, you can maybe even think of a trap like that. You know, you put something that's smaller on one side and bigger on the other side, and then it's gonna trap something inside there. All right, but that's a trapezoid, one set of parallel lines, and the others are not. All right, and now we have a rhombus. A rhombus. A rhombus is just a fun word to say, but its sides are equal length. All sides are equal length. So if I were to get, well, and we can do this with just using my pen here. All right, so I'm going to make a line that goes all the way across the top there. Now, I'm going to go back, and I'll do the same here. I'm going to do the same here, and then I can switch over to my mouse here, and then I'll show you. So, we know that this is the same there, okay? So let's take it and flip it to the side. Let's see if that side is that same length. Yep, side's the same length. And we know that the top and the other side are because it has the same look to it. Now, what about this one over here? Remember what we called it before? We said it's a parallelogram because we said it has two sets of parallel lines. So let's take it down here. Yep, same size. Even though it might look a little weird being off to the side, they are exactly the same size. Now if I turn that this way and I line it up over here, there it is. Same size. Same size. So these are called rhombuses. That square, what we call a square and parallelogram, right? These two are rhombuses. We call them rhombuses as well. All right, so a rhombus has 4 equal sides. 4 equal sides. Now we'll go back again. Trapezoid, one parallel lines, the other one is not. Parallelograms, 2 sets of parallel lines. And then, of course, quadrilateral just means it has 4 sides. Okay, so now we're going to look at the rectangle, which we already know it's called a rectangle. When we see this shape, we go, oh, that's a rectangle. Well, why do we call it a rectangle? Why is it considered a rectangle? Well, it's considered a rectangle because there are 4 right angles, those 90-degree angles. They're right angles, and there's 4 of them, so we call that a rectangle. Now, a square has equal length sides and 4 right angles. So a square has to have 4 right angles and 4 sides that are exactly the same. Now sometimes this can be confusing because a square is also a rectangle. A rectangle has 4 right angles and 2 parallel lines. So does the square. The square has 2 sets of parallel lines and it has 4 right angles. So a square is a rectangle. But a rectangle is not a square because its lengths of the sides are not all equal. All right, so this shape here, we commonly call it a square. But it is also a rectangle because it has the 4 right angles. It's also a parallelogram because it has 2 sets of parallel lines. And it's also a rhombus because all lengths of the 4 sides are the same size. So that, what we commonly call a square, is also a rectangle, parallelogram, a rhombus, and a quadrilateral. So, 5 different titles that we can put on this. A square, a rectangle, a parallelogram, and a rhombus, and then the general category of a quadrilateral. Okay, so here we have 4 shapes. Which one doesn't have parallel or perpendicular sides? Now remember, parallel sides, they run side by side and they're never going to touch. So let's start with that. Do we see parallel lines on different ones? Let's go to the pen. And, all right, let's check it out. All right, so here I see parallel lines here. So, yep, has parallel lines. Oops. Okay. Over here, I see parallel lines. Yes, for the parallels. I'm just going to put parallels like that. Does this have parallel lines? I see the top and bottom are parallel, so these have parallel lines. That's not parallel, that's not parallel, so no for the parallels. So now let's check the perpendiculars. the perpendicular. Okay, that means, just like you see there, that they're going to intersect and make a right angle. Well, these have right angles, so yes to the perpendicular. These don't have right angles, but it says or, so it doesn't have to have both. Here, perpendicular, yep, I see that corner, that nice corner there, so yes to the perpendicular. Here, no, that's not perpendicular, that's not that nice situation there, so no to that one too. So which one doesn't have parallel perpendicular sides? This yellow one right here, the yellow one. And if we look at this one, we can call that, like we said, a square, a round is a parallelogram, and a, my mind just went blank. Rectangle, yes, that was the other one. Over here, we have a parallelogram. This one's just a quadrilateral. It's just a four-sided figure. And this one, we call a quadrilateral as well. And actually, this one, because it has one set of parallel lines, what do we call that? Let's go back and check. One set of parallel lines. Exactly one pair of parallel sides. Oh, well then we can call that one a trapezoid. Oops, my hand got my, okay. Trapezoid. Okay, so a trapezoid, we have a parallelogram. And we have a square, roundness, that one that gets a lot of use out of it, huh? Alright, we'll just call it a square. Okay, now, I want to look at the angles of things quickly. So here, this is what we call an acute angle because it's smaller than that 90-degree angle. Okay, we already kind of talked about right angles. These are all right angles. If I look at this yellow figure here, let's look at the angles here. So I want to figure out, is it larger or smaller than that 90 degree? It's not 90 degrees because none of them have the perpendicular angles. So this one here, when I look at it, if I think about making that straight line, it's just going to be a little bit out from there. So this one is acute. It's just a little bit smaller. It's not a right angle. This one here is a little bigger, so it's obtuse. This angle is bigger than the 90 degrees, so we call that obtuse. And then this one here is smaller, so we call that, again, acute. So this one has two acute and two obtuse. This one has two right, one obtuse, one acute. This one has an acute, an obtuse, an acute, and an obtuse. So if it's not one of our special ones here, most of the time we're going to find two obtuse and two acute angles if it's not something special, if it's not like a square or a rectangle, because we need it to equal up to 360 degrees there. Yeah, so that is your ideas for today. One more thing I want to talk to you about with your homework. When you're doing number 12, okay, it says you travel an average of how many miles per hour. When you're doing that one, it says explain why your answer is reasonable. You don't have to explain why your answer is reasonable, but just show me, your math, okay? Show me your math. That's good enough for number 12. When you are doing, well, you don't have one with it today, but when you do a problem that has something that says like 2 to the third power And then something else, but 2 to the third power, I just want to remind you, the 3 tells me I have how many 2's I need to write down. 2, 2, and 2. That 3 tells me 2, 2, 2. Then I can multiply them together. 2 times 2 is 4, times 2 equals 8. It's not 2 times 3 equals 6. Okay, that's a common mistake that happens, and I just want you to make sure that when you think about 2 to the third power, you think, okay, I need 2 here, I need a 2 here, and I need a 2 here. It is not the same as 2 times 3. All right? The rest of those should be okay. If you do have any questions, let me know. And I hope you have a great day. And you have 2 weeks left. So keep up the good work, and soon it will be summer.